Okay, in this follow-up video, we're going to take a look at solving different types of problems with triangles, possibly using sine law, cosine law. We have to talk about something called compass bearings and directions. So once you get used to the system, again, it's just a matter of using this new system to be able to draw triangles and then use the typical systems that you would to solve triangles that you've seen in other videos and lessons. All right. So a compass, obviously you must have heard of a compass at some point, where it always points northerly direction, but there's different ways of talking about directions using a compass or using just directions in terms of north, south, east, and west. So north can be represented using 0 degrees or 360 degrees, east would be representing 90 degrees, south representing 180, and west as 270. And that's with the the compass directions. So just to show you how that works, I'm just going to draw the bearings. So right in through there, you very much set it up like a Cartesian plane. Okay, so in terms of north, compass bearings, you always start here and measure them. That's just the standard way for measuring it. So if you start here, this would be an angle of 0 degrees. Or you go all the way around, and that would be 360 degrees. As you can see, a nice little circle on there. All right. East, which is over here, that is a measurement of 90 degrees from the starting point. So you always start here at north and then go in this direction, which we call clockwise, and measure from there. So south would be that many degrees, which is 180 from here to here. And then west would be 270 degrees from there to there. Not quite the full circle. So just from there to there. Okay. All right. It's always written with 3 digits, these compass bearings. We'll look at directions in a minute. All right. So for example, a bearing to a point 065 degrees. So again, start at the northerly line, measure 65 degrees from there, and that's how you get to your bearings, 065 degrees. All right. Q is at a bearing of 300. So again, starting here, we would measure 90, 180, 270, plus an additional, correct, 30 to get to the 300. Okay, so this little piece in here would be 30 degrees, but the entire bearing system would be 300 degrees, right? Go all the way around there, there. Okay, so again, you always start in a northerly direction. That's how this system works. Once you get the system figured out, then it's not too bad. So it can get into little language issues. So the bearing of A from B. So you have to think of yourself as standing here at B, looking at A. What would be the bearings? Well, if this is 65 degrees, then the bearing would be 065 to get to A. Whereas the bearing of B from A, so from A implies you are standing, so from A and looking at B, what measurement would that be? Well, again, if you're measuring using bearings, then it would be that angle right in there. Okay, and that happens to be 245 degrees. Okay, now in terms of how to get the 245 degrees, well, you're going to have to remember patterns that you did in previous courses, like Z patterns. So you have these alternating angles. So if this is 65 here, this would be 65. This is 180 plus the 65. Guess what that gives you? 245. All right, so it is a bit of a complex system. So we're going to have to get used to it. So we're going to go through a couple little examples here, and we'll just manipulate from there. Okay, so this particular one here, again, measuring from north to P, that measurement there is 48 degrees. So the bearing, though, would have to be written as 048 degrees. And I'll just put that little degree symbol in there. Okay. And then in B, for this P, if that's 60 degrees, then we're going to need to be able to measure from here to there. So that's going to give us, well, that's 180 plus the 60. So the bearing that we're looking at is a bearing of 180 plus 60 degrees, which is equal to 240 degrees. Okay, so that would be the bearing. 240 is actually the way it would be pronounced. In C, if we have a little angle of 40 degrees down here, so again, we're trying to measure this out, starting at north, going there. Now, one way to do this, a little bit different than the previous one, there are different ways. If we measure the entire from north to south, that'd be 180, but we don't want all of it, we want just 40 less than that. So you could measure it this way, 180, take away 40 degrees, which would be 140 in terms of a bearing, that's how you would pronounce it, 140 degrees. Okay. And similarly, with this last one here, again, measuring from north, that's 90, 180, 270, plus that little 20. So we have 270 degrees plus the 20 gives us a grand total of a bearing of 290 degrees. So again, it's a matter of making sure you have the diagram set up properly and then using the system that's appropriate to get the measurement that you want. But again, in terms of pronunciation, bearings are always just listed with digits. So 140, it wouldn't be really a 140 bearing, it'd be like a 140. And the 290 would be 290 degrees in terms of a bearing. So that way people know it's a bearing and not something else. All right, in terms of directions now. Directions, this is what you're probably a little bit more familiar with in terms of compass directions anyways. So we have north, south, east, and west listed. That's the N, W, S, and E. All right, and we're just trying to identify the directions to try and get to these various points. So point A, if you take a look at the notation here, is north. So we have north, go north, and then turn 30 degrees towards the east. So that's one way you could write it. Now usually you start with north and south, but sometimes you could say east and then rotate this many degrees, and that would be 60. So you could say east 60 degrees north. That is another option for you. And that's the unfortunate part with some of these systems, is that there's more than one answer. Okay, so you got to keep that in mind. Lots to keep in mind with these sorts of things. Okay, and for point B, which is over here, now again, this is not bearings, but you could start with the north as well. So if you start north and then rotate this direction, which is towards west, so north 60 degrees to the west. Okay, so that's how you would get that measurement there. Let's just clean this up a bit. All right, and then for C, now C, again, you can have, if this is 70 degrees, and this measurement must be 20 in here. So you could say east, and then rotate downwards towards south, so east, and then 20 degrees south. But again, the likely way that you should be indicating these, or the more conventional way, I suppose, south, and then rotate that way to get to this arm. So if you're rotating that way, you're rotating towards this east arm 70 degrees. Okay. And then lastly, D. So D, again, if you started with south and then rotated this direction towards this west arm, then you would have south 80 degrees to the west. Okay, so those are some very conventional to start with, either north or south. And then the numbers that you use for this type of directional measurements, the angles should always be less than 90 degrees, unlike the bearings, which you can have greater than 90 degrees. Okay, so that's important to get through the language, because the word problems will contain a variety of different things to take a look at. And once you get past the diagrams, so it's the diagrams that are the biggest issues. If we can get the diagrams sorted out, then everything else should work out fine. So here's how you have to interpret things. So Shirley takes her dog for a walk in a no-leash zone, Glen Abbey Rec Center. Entering the gate, Shirley unleashes Fido. So if she unleashes Fido, then Fido is going to get released at some point, right? Fido walks 150 meters heading south 25 degrees east. Now, let's try to draw this out. So if we want south and then 25 degrees to the east, so I'm going to rotate towards this arm, south, and then only 25 degrees rotation in the direction of that arm, or that direction east. Just going to put a little arrow on the end of it. Oh, I guess there is one there. I probably can't see it. There we go. Okay, so we have 25 degrees in here. So now I might be exaggerating the size of it, but sometimes exaggerating helps, sometimes it doesn't. We'll put that in there. So there's the 25. And then there. He then sees a cat. Now when it says he, we're talking about the dog. So he then sees a cat and runs 75 meters heading south 5 degrees west. Now before we go any further, we probably should mention that the distance for that green measurement is 150 meters. So probably not a bad idea to label that as well, because that'll help. Now, if we have to change directions from where the dog is right now, so the dog is now here, probably not a bad idea to recreate some kind of Cartesian plane looking thing. Okay, and the reason for that is you want to be able to try to make this sensible to your diagram that you're going to need later, right? So the first one we did a little rotation, and again I'm going to just make sure you understood that the rotation that we're looking at here is south, and then we turned towards the east. That's this one here. So now the next rotation is going to be starting from the next little Cartesian plane. So we want south 5 degrees west. So south 5 degrees to the west. Now that's not a big measurement. All right. So the 5 degrees is going to be in here. Now it's going to be a little hard to label, so I'll do my best to put that in there for you so you can see it. And again, it might be slightly exaggerated in terms of the size, but that's okay. Again, we're just using this as a reference diagram. And travel 75 meters. All right. So that's something else we'll put in there. So this measurement is 75 meters. Trying to keep it color coded as well. All right, now, so we have to keep in mind where all these angles are, and I'm going to keep track of everything. So we have 25 degrees here, 5 degrees there. And the question is asking for, let's see here, how far is the tree from the gate, sorry. So Fido ran and chased this cat up the tree. So there's the tree right there at this point. And the question is, how far is the gate from the tree? So what we're asked to find is this measurement right there in red. Okay, so that's what we need to find. And I'll just happen to change the color to match. So we do not know that measurement there. And that's what we're asked to find. As you can see, the green, black, and red lines have created a triangle for me, which is good, but it's a matter of piecing it all together to see how we're going to get some measurements here. And this is where you have to try to keep in mind all the angle measurements that you've used in the past. Try and figure out what some of the angles are. Now, let's see if we can work this out. So in terms of trying to get an angle in this diagram, well, the 25 seems to be split in pieces. We got a 5 here. So if this measurement is 5 degrees, how much should this be between here and here? Correct, should be 85 degrees right here, because these two, that's a 90 degrees, and if we're removing 5 of it here, then that should be 85. So that's helpful. Now, with the other angle, it'd be nice to know if we can get this angle in here. So we have this piece is 85. If we could get this piece, that would be helpful. Let's see how we could do that. Well, this is where I talked about, patterns. So let's see here. So we have a couple parallel lines going this way and this way. So that means that this angle of 25 degrees must be the same as that, which is 25 degrees. So if this is 25 and this makes up a 90, how much should this be? Correct, it should be 65. So we have a 65 and an 85 that are going to total to, whoops, sorry about that, going to total to 150 degrees. Now, once you have this all set up, it's not a bad idea to maybe try and come up with a different triangle. And then just relabel it using, so you kind of envision what this triangle shape would look like. And as you can see here, I've got the labelings pretty much the same. And the measurements, I've put some variables in there, right? So I've got the 75 meters for this portion down here, the 150 up at the top, and then I put those angles in there for a reference. And then this is the part I need to calculate, so I replaced it with an X. So now it's a matter of kind of forgetting this whole system and just say, well, now how do I find X? So is it going to be sine law? Is it going to be cosine law? What is it going to be? Well, I have this angle, and I need to find the opposite side. So that could be sine law, but I don't have any other information. Cosine law would work because you have the side lengths that help contain this angle. And there's your cosine law. Okay, so once you have the formula, the diagram figured out, that's the hardest part. The rest of it is just supposed to be pretty easy. And just doing the straightforward calculations, get the right formula in terms of whether it's sine law, cosine law, or SOHCAHTOA, and then go from there. Okay? So that is the hardest part, just getting this diagram. So that's what I'm going to focus on in the next couple of examples as well. So in this next example, you have 2 forest rangers observe the same fire from their observation towers. All right. And Renee's tower is 19 kilometers due east of Sarah. So again, we have this little system here. And let's see how this is going to help us out. All right, let's just get set up. Okay, so so Renee's tower is 19 kilometers due east of Sarah. So how does that work? So let's see here. So if Renee is east of Sarah, okay, so Renee's tower is east of Sarah. So Renee has to be somewhere over here. That's going to be Sarah, right at the beginning. So we'll put a little capital S there for Sarah. And once this disappears, it'll be a solid dot there. It's not disappearing on me. Let's get rid of that on that. Okay. So let's try this again. So this would be Sarah. And then Renee is over here. And Renee is due east. So due east would be that kind of a measurement. All right. So there's Renee. And I do have that distance in there, 19 kilometers. So I can write that in. All right. Now, they observed the same fire from their observation tower. So Renee's tower is 19 kilometers east. So I've got that sort of set up. So Renee sights the fire on a bearing of 305 degrees from his tower. So this is where it's important to say, okay, well, from Renee, I have to now measure 305 degrees. Now, how do I measure that? Oh, let's see, 305 degrees bearing. Start here. That's 90, 180, 270, 305. I need another, how much from 270? Correct, I need another 35 degrees. So another 35 degrees from this point here. So I'm going to go on a 35. So from here, I need another 35-degree angle to try and get to this fire. Somewhere in there. Now, I'm not going to complete the diagram just yet. I might have to shorten this. We'll see how things go. Now, Sarah sights the fire on a bearing of 32 degrees. So for her, bearing, whoopsie, the bearing starts here, north, and I have to rotate 32 degrees. So in the same direction, but 32 degrees. Now, between here and here is 90. So that's 45. So 32 is somewhere up here. So I'm going to try to make this reasonably accurate. So that's about, let's say about there. Now remember, this was only supposed to be about 30 degrees. So I'm going to extend this. All right, so let's put some measurements in here. So remember that this was 270 plus the 35 degrees in here. Okay, so we're going to put 35 degrees in that little corner over here. So we have that measurement. And then we have another measurement of this here, which is 32 degrees. So you can see how we're shaping the measurements right now. So we have this kind of set up right about here. So that way we got the diagram partially set up. And the other thing to note is that we have to indicate where this fire is. So the fire is going to be right up here. Let's put the word in. Why not? Okay. So they're locating this fire in their own respective manner. So as you can see, there's information in there. You can clearly see the triangle here. And you're asked to find how far is the fire from each tower. So it's the two red lines that we need to kind of sort out. And that's where you're going to have to come up with a separate diagram. And to see how this separate diagram works again, so you can clearly see where the triangle is. Now it's a matter of getting angles on the inside of the triangle like we spoke about before. So if this is 32, this is not a hard calculation at all. That's just the 90 minus the 32 to get this angle in here. And then we can easily find this angle up at the top of the other triangle. So let's take a look at a separate reference diagram here. Okay, so hopefully this kind of gives you a little bit of information in terms of what's working with the information we had previously. I'm just going to get rid of some of the stuff here that I don't need. Okay, so in terms of the angle measurements, we already established that this green one was 35. This is 58 because of the 32, as we discussed up here. We can calculate the top one as 87. So now we have all three angles in the triangle. We have one measurement here. And we need to find, and again, you can use the capital letters, the distance from Sarah to the fire, and from Renee to the fire. And you can use lowercase letters in your formula if you'd like. right? And they can be R and S because they're opposite the capital letters. And notice how the sine ratio helps quite a bit here. So you have a complete ratio here because of that angle and that side length. So as soon as that's established, that should allow us to find the opposite ratios. So there again is the sine law. And we're asked to find the two distances R and S. So much like we've done in previous questions. It's just a matter of setting up the ratios accordingly, solving them separately to come up with the different values, and then write a concluding statement. Okay, so the absolute hardest part about these word problems is creating the diagram. Once you get the diagram set up, create a triangle reference diagram, and then from there it shouldn't be too bad to establish whether it's a sine law, cosine law, SOHCAHTOA, maybe a combination thereof, and then setting up your diagram of your variables, and then using that to find a solution. Okay, so we're going to take a look at one more. This one's going to be a little bit easier. So you have a radar screen and an airport tower. Airport control tower shows that two planes are on the same altitude, so same height. Now we're not doing 3D diagrams, so according to the range finder, one plane is 100 kilometers away in the direction of north, 60 degrees east, and the other plane is 160 kilometers away in the direction of south, 50 degrees east. How far apart are the planes? All right, so let's take a look at the diagram for this one here. Now, this one's a little bit more simplistic, simply because we don't need the dual rating. So this here is the A for the airport control tower. All right, so one plane is 100 kilometers away. That's what the 100 kilometers does mean, in a direction of north, and then go towards the east 60 degrees. So that's where that's coming from. And then you draw that line in there. The other plane is 160 kilometers away in the direction of south, 50 degrees to the east. And that's where that measurement's coming from. Now, since 160 is bigger than 100, not a bad idea to draw that line longer than the first line that you drew. Okay, just to give you the proper impression. And how far apart are the planes? So it's this distance there that you're trying to find, that D. Now, do not, just because it looks like 90 degrees in here, because of the way the diagram's set up, do not assume it's 90 degrees. You cannot assume things are 90 degrees unless it's very logical to assume that. Like when a building is standing on the ground, that's 90 degrees, okay? In this case, even though the diagram looks like 90 degrees, you cannot assume that that angle is 90 degrees. These are planes in the air, okay? So it's important also that they're at the same altitude. So that gets into like 3D type of geometry, which is a much more complex system. So if we're trying to find that D, we pretty much have the diagram completed the way we need it. So we have the two distances here. We can get this angle, which isn't too bad because this whole angle is 180, but we don't want this 60, we don't want that 50. So the remaining part is 70. So this angle A is 70 degrees. And do we have completed ratios anywhere for sine law? No, we do not. But we do have two side lengths. We're trying to find a third. And we have the contained angle. That points us to cosine law. Okay, so there's the D and angle D. Or sorry, angle A in this case. So sorry about that. So the labeling is a little bit different than maybe what you could have drawn. But don't worry about that. It's the side length that is opposite that angle. Okay, so the side length is D, and that's opposite that 70 degrees that's in there. All right, and once you have that established, again, it's just straightforward calculating, taking the square root to get your D value because it's D squared to get your answer for the distance apart. And that concludes going through some of the more complex problems with bearings and compass direction. So hopefully this will give you a little bit more insight and helpful information to understand and deal with these types of problems.